Intelligent microscope, automated TB diagnosis via embedded deep learning. Tuberculosis, known as TB, is caused by bacterium cells called Mycobacterium tuberculosis. The bacteria usually attacks the lungs, but TB bacteria can attack any part of the body, such as the kidney, spine, and the brain. Tuberculosis is one of the most dangerous and deadly diseases that infects humans. According to WHO, more than 10 million patients die every year because of tuberculosis. One of the most widely used tests for TB diagnosis in developed parts of the world is the microscopic examination of Zine Nelson. However, accurate diagnosis depends on the availability of experienced, skilled lab technicians, which is a problem particularly in remote, rural, and resource-limited regions that are mostly affected by the disease. Yet, early diagnosis of tuberculosis can lead to quick treatment that delivers wider opportunities to reduce its deadly effect. We attempted to design and implement an alternative way to detect tuberculosis, using the finest cutting-edge technologies of embedded deep learning and 3D printing to provide a fast, reliable, and dependable diagnosis. Turning laboratory diagnosis from art into science, of which a smart machine learns from the experience of skilled human experts and is able to mimic their examination and diagnosis skills without their supervision or even their presence. Regarding all the mentioned, we have decided to use nowadays modern technology to design and implement an intelligent microscope that is able to accurately identify tuberculosis bacterial cells on its own. Our team has developed a deep learning-based method that uses attention-based learning to accurately classify the whole slide of the symptom sample. Deep learning is a part of a broader family of machine learning methods that aims to teach the computer how to act according to existing data. Embedded deep learning enables electronic systems to learn autonomously from existing data and to use this acquired knowledge to independently make assessments, predictions, and decisions. Our project has run into different milestones. Collecting dataset was the hardest and most important stage in our project. A dataset of hundreds of photos of symptom samples were collected from Asyut University Al-Qasr Al-Aini Hospital. We captured them using a camera mounted on a microscope. The samples were labeled by the hands of an experienced medical professor to acquire a classified data set of samples. Based on the dataset, we have built a deep learning AI model, which was trained on the mentioned dataset. The model takes a magnified, colored photo of the sample as an input and provides a percentage for the possibility of infection as an output. Thus, the model will be able to predict the infection automatically. We have tried a lot of deep learning models, such as SVM, KNN, Faster RCNN, and YOLO version 4. The best model that has provided us with the best accuracy was YOLO version 4. The accuracy exceeded 95%. After the trained deep learning model was ready, it was deployed on a NVIDIA Jetson Nano to achieve real-time analysis of acquired images. NVIDIA Jetson Nano is one of the most advanced microcomputers dedicated to embedded deep learning applications. Using the design of the OpenFlexure open source microscope design, we used 3D printed components to create the microscope body and stage and to contain the optics module. We have chosen to use the OpenFlexure design because it is open source, cost-efficient, and portable. The NVIDIA Jetson Nano board was positioned on the manufactured microscope. A special-purposed camera has been mounted on the microscope to feed the NVIDIA Jetson Nano with real-time images of the pathology slides. The microscope would also traverse through the entire slide using a special robotic mechanism to avoid human interaction with the samples during the scan. The medic will receive the results of each slide on our mobile application designed specifically for this purpose. The mobile app connects automatically to the microscope and provides an easy interactive user interface with the microscope. Using the mobile app, the medic can order the microscope to start or stop scanning the sample, acquire data regarding the currently scanned sample, and review the history of previously scanned samples. Currently, the system is being evaluated by specialists at TB Lab, Asyut University Hospital. We hope for our project to be implemented at as many hospitals as possible, to benefit all patients who are in need, and to help increase the quality of medical service in poor countries.